talk about piping. So here we'll look at redirection and pipes for combining multiple commands, how to filter output and variables and environment variables. So how do I redirect output? How do I pass output from one command to another command? And how do I combine multiple commands? Can I sort and filter this output? And also, what are environment variables, which we have touched upon briefly when we talked about the $home variable, which is a very useful, very commonly used environment variable for your home directory. So we'll learn how to redirect output and to pass it from one command to another, to combine multiple commands, to sort and filter it, the output we get, and also learn a bit more about variables and see some useful environment variables. So there is a command in Linux that is called echo. That is quite useful. It lets you display lines of text or string that are passed as arguments. It is quite commonly used in shell scripts and in batch files to output the status text to the screen or a file. You can also use it to see the content of an environment variable, or as a means to quickly send text from the command line to a file. So it's just called echo, and then options or flags to it, and then a string. Again, you can use man echo, and then you can, there's something missing here, but the command is echo string that you want to display or do something with. So why don't you try it out? You could simply type echo, and then a string that says something. I am learning in Linux. And then it returns, I am learning Linux. And that is also useful. For instance, you can say echo, and then the one environment variable we talked about before, which was $home, echo $home. It tells you what is in this environment variable pointing to, and it's pointing to my home directory. And we will look at echo again later. It's just that we need to introduce it now. So redirection and I/O redirection. Usually standard input from keyboard and standard output will go to the screen. There's also a standard error, and you can redirect all of these with the Linux commands. If you have a greater than, it redirects the output of some command. For instance, NAISS, to test that. That means the output of NAISS command will be put into this file. These two greater thans concatenate the output of some command to the content of a file. So that is, you have some output, you throw it to a file, and then some other output you put to the same file. So that concatenates it or adds it to the content of that file. Let's then change the standard input to greater than redirect standard error, and then if you add an ampersand and a 1, then it takes both the standard output and the standard error and does something to it. So let's try and repeat echo, for instance this here, and then throw it to file test. Okay, and I will see what is inside this file. There is the content I just put there. I'm now going to concatenate stuff to it. So I could take ls, and this ls, I'm going to, for the output from ls, I will concatenate to haha text. Let's see. It did. So now it has this content. So that worked. And, you can try and also you can also do this with. So if you take this output here that I just got on the screen from my file haha.txt, so I get an output, and then I'm going to send it to another file haha2, and I'm going to do it again. So I will concatenate it to it. And I could also append some content. I could echo some text there. Just like before, I echoed this is a new line of text. If I just say that, it goes to the screen. If I instead says echo the string I want to say, and then append it to this to text, it does so. And let's see what is now inside of this file. I will try and use less on to text. And now it has all this content, and at the end this is a new line of text, because that is what got appended or concatenated to it at the end. There's another way to append it with printf. And just give the command, because if you do that, then it will tell you how to use it. And I'm just going to use it by taking a line of text. So more text here. And if you do a /n, that means a new line afterwards. So let's try to do that. And we again put it to the same one. Let's try look at haha to text now. And go all the way to the bottom. And now the line there, some more text here, is added. And also, if you want to add a larger block of text using the command line, then you can just open the file for writing, cat, and then typing to, okay, we call it foo.txt. And now this file is open for writing, so I can start typing. Typing stuff. Needs more content. And just one more line. Then I am going to save this. I do that with holding down Control and typing D. And that means it ends it. And let's see what happened. We got a file foo.txt. It is here. I'm going to look into this file. This time I will use nano. Even though I said we shouldn't to just look in files, but I'm going to do that. And you can see here is the whole content. I can now exit it by holding down Control and typing X. And it makes, since it wasn't modified, it just closed it. So let's assume I have a huge file. I just want to see what is inside of it. I don't want to look through all of it because I know what I'm looking for is one of the first lines or one of the last lines. I can use head and minus n for the number of lines, and then the file name, or tail minus n for the on the file for getting the last n lines instead. So I have a file, my file 3 somewhere. I believe, yes, that one. And I'm going to say head minus 3, and then my file 3 text. Then it gives you the 3 first lines. If I instead say tail minus 3, my file 3.text, it gives you the last 3 lines. If you say cat, it gives you the 4th one. So you can play around with that. And the one that's called my file 3.text has at least some lines. So this should be enough to at least try this output. And I'll just wait until 10:55 while we test this. So I will continue. I previously mentioned that there were commands for sorting. And there's commands for word count as well. WC means word counts. It counts lines, words, and characters in files, and it returns the values in that order from left to right. And you can do minus L to get a number of lines per file, minus N is a number of characters per file, and minus W is number of words per file. So let's try and do this. Let's try to do these exercises here, and I suggest you also code along here. And you can go into the directory exercises, into patterns, and that is where I am right now. I have all these files here, and I'm going to try just say WC on one of the files. I took my file.text, and then I remember there is no such file. This goes my file 1.text, and then it says how many lines, how many characters, and how many words. And if you want to, you can open it and count them. But I did, and it was correct. So what if you wanted to do the same thing for every single one of the text files here? Then we are using this wildcard that we will shortly talk about in the next section. But this just means I will do it on all the files ending in .text. And then I get this output here, where it shows for each one of these files how many lines, how many words, how many characters. And that can be quite useful. So what if I only wanted to know how many lines? I can do that with the minus L. And sure, let's do that for my file too.txt. And it tells me there are 2 lines. And if I just say WC and I don't give input, it waits for input. It assumes you will get something. So that is one way that if you make an error, you just type this, then you can always escape it. With Control, hold that down and type a C, then you exit it. Okay, so what if you had a huge number of files that you want to run word count on? Then maybe it doesn't work well to throw it to the screen because you get a huge output, and you could already see that this output here was almost too much to fit on the screen. So you could simply use piping to redirect it to a file. So let me do that. So I say I want to count the number of lines in all the text files, and I redirect it to a file that I call file length text. And then let's do cat on file length text just to see what's in it. And here, for each file, is the number of lines. And it was very long. It wasn't very long, but long enough that maybe you want to use less to look at instead of cat. Okay, so we have now talked about word count. Let's talk about sorting. There's a command called sort, and that command is used to print output of a file in a given order. It has quite a number of options. Some useful ones to use, common ones, are -n, where you compare according to a string numerical value, -f, to ignore the case, or -b, ignore leaving blanks. In the exercise patterns directory where you are, there is a file called numbers.txt, and it will be useful for this. So let's try and sort it. First, I will show you what is inside of this file. It looks like this. It's just some numbers and they're not sorted. So I say sort numbers text. This. And it sorted it, but maybe not the way you wanted it to, because the default way it sorts it is maybe not how you thought about it. I mean, it sorts it like this here. So let's tell it we actually want to sort it by string numerical value instead of the alphanumerical. Let's do that. And now it sorts it as you expected it to. Maybe as you expected it to. What if we do the same for the one file that we got as output for the word count? And as you can see, this way you are slowly building up to something that might become a script at a later point. So it sorts it and it extends it to this other column that contained the file name. So let's talk about pipes. Pipes are also a sort of redirection. And they are used when you want to take the output of one command and use it as input for another command. Often you say, I pass the output to another command. And in many cases, it's possible to do the same with an intermediate file or more, but it's often better to just combine the commands with one or more pipes. And a pipe of this kind is symbolized by a straight line between the commands. Code along. Let's try. The files in the directories exercise/patterns again. Just a little while ago, we counted the lines in all files with extensions.txt. We throw the output to a file. Let's instead try and pipe the output to the sorting that we just did and sort it numerically. So let's say WC, word count, number of lines, all text files. And now we pipe it, we pass it to the command sort, and we want to sort it in the regular way, numerically. And then we actually got the same output here, as you can see. So we did all of that in once. We could also instead use, for instance, tail. So we are now counting the number of lines in all the text files. And then we are saying we want to see the 3 last lines. And that looked like this because I didn't sort it. If I also sort it, by the way, arrow up, if you use that on the keyboard here, then it will give you the most recent command. You can cycle through them by typing arrow up. That is quite useful. I am going to modify this line here. So I am first counting the lines of all the text files. I am sorting them numerically. I am taking again this output and I'm sending it to the command head in this case. And take the first 3 lines. So the file got lines got of all the text files got counted. It got sorted numerically, and then the 3 top ones were output now with the head command. And you can see this way you can very quickly build up something that is a lot more powerful and easy to work with than having to go through them in some more manual way. So let's go to exporting variables. And one of the environment variables you saw before was $home. The reason for environment variables is that we use them to store data that we use by the operating system and by other programs. Some are intrinsic to the operating system. Some will be for a specific program, library, or programming language. And some are some that you have created as the user. You can use the variables in scripts. You can use them on the command line. And to reference them, usually you put a special symbol in front of them or around them. By convention, they are uppercase. There are some examples here. These are just examples. It doesn't mean you need to know them, but it's just examples. So $home is your home directory. $pwd is a variable that points to your current directory, same like the print working directory. ld_library_path will contain a colon-separated list of directories that the dynamic linker should search for shared objects before searching in any other directory. We can try types of this. You use echo to see what's inside of an environment variable. So echo $home, my home, and echo $pwd will give the same as just pwd. And let's see if I have something in my library path. I do. It's not very important what's in it. I just wanted to see what is there. And if, say, you were doing an OpenMP program, you could do the environment variable OMP non-threads. Or if you used Python, maybe you use the $Python, so Python path rather, to where you install libraries and packages. These are just examples. If you type env, you get a long list of environment variables that are currently in your set in your environment. And it will be a fairly long list because there's a lot of stuff that is set automatically. So how do I set an environment variable? You do that with export in bash. Export the name of the variable without the $sign and equals the value you set it to. And if you are using C shell, which is also common, then you use instead set env, the variable and the value. You can create your own variables in scripts. We will look at it a little bit on the script. And these are just some examples. This is how you would set OMP non-threads to 8. How you would add a new path with export the variable equals, and you add to it in this case because you want to keep that what was already in the path, which is this environment variable. You put a colon and the new path. Warning, this is important. Environment variables you set like this only retains the value for the duration of the session. If you open a new window, if you log out and log in again, you need to set it again. To avoid it, you can add it to your bash rc file. But only do it if you really want it to persist across sessions. And that is probably the case if you're setting the LD library path or the Python path or something like this. But let's see. I will just say cd, and I'm now in my home directory. And then I will show you the file bash rc, which is a configuration file for what that will run when you log in and other things. And you can see there's very little in it. It's things that are automatically set. But you can see there is a type of path here that tells it where to look. And it looks in your home directory under some specific places. So you can take a look at it if you want to. Well, this is a place where you would add stuff you want to be persistent. And you could use the echo command, of course, to throw a string that contained this export of the variable and appended it to your bash rc file. So, okay.